Hi, this is Yash. I'm a third year mechatronics student, and this is our project demonstration for the course Mechatronics Design 2, MSE 312. So in this project, we have a robotic arm that picks up an object from one position and drops it to the other position. And the goal in this project was to do it in the shortest possible time. For our design, we started off with our mechanical design. The goal in the mechanical design was to build the robotic arm that could be as light as possible and could carry a heavy mass. So we started off with the designs. We came up with 3 designs in SolidWorks, and we simulated the FEA analysis and conducted FEA analysis on each of these designs. And we went with the one that had the smallest deflections and had the lowest moment of inertia, so that we could do the operation as fast as possible. The second aspect of the project was the electronics design. For the electronics design, we used an Arduino to generate PWM signals to run the servo motors. So we have 3 servo motors in this project. One is for the base, rotating the base of the robotic arm. One is for rotating the links of the arm, and the other one is for the gripper. We use a Arduino to generate PWM signals, and we are powering it off a 9-volt battery to 3 motors, and then we're using a voltage regulator to regulate the voltage requirement of the servo motors. And talking about the controls aspect, we have Arduino program that programs the servo motors to the desired rotations needed for a project. Initially, we had to calibrate the servo motors to our desired angles to figure out at which angle does it consider 0 degree, and figure out which angles are necessary to program the robot. We're just going to go through the quick demonstration of this project. So that was a demonstration of this project, and now I'm going to go through our simulations in our Simulink file that helped us with designing the software and the controls aspect of this project. So as you can see in the Simulink file, we have simulated a DC motor which generates PWM signals that powers the DC motor, and we have simulated a load that is equivalent to our mechanical arm, and we input it to a desired rotation. For example, in this we have a position control loop that rotates it to an angle of 90 degrees. That's around 1.5 radians. And as you can see in the control design, it reaches its steady state value of 1.5 radians, which is close to 90 degrees in close to 4 seconds, which is exactly the time it took us in our physical prototype. Thank you.